This is a demo of the Arduino-based collision detection system developed at Texas Tech University. I am Zachary Brazel. This system was developed in conjunction with Clinton Beasley under the direction of Dr. Lim. What you're looking at now is the server of our proof of concept system. It's driven by an Arduino Uno Rev 3. It has a GPS unit and a NRF 905 radio unit. The GPS communication is handled via a UART, and the NRF 905 communication is handled over SPI. This right here is a voltage divider because the NRF 905 logic operates on 3.3 volts and Arduino Unos operate on 5 volts. This guy, once he gets a fix with his GPS, he will squawk out his coordinates, his lat long in degrees, via the 905 on the 434 megahertz ISM band. The range on this unit is about up to a kilometer under ideal conditions. In urban conditions, it is around about 100 to 200 meters. This brings me to the receiver. This is a simple receiver that has a 905 and a Bluetooth unit. The exact same 905 that's on the sender. Same Uno, a little bit different firmware due to the absence of the GPS and the addition of the Bluetooth. The Bluetooth communication is also handled via UART, and you'll see on the combined client later, it's a little bit of a additional headache, but pretty cool nonetheless. This guy, he receives the coordinates, doesn't do any calculations or anything, just simply relays it to a smartphone app, which I have running here. The coordinates are squawked out about every second or so, and you can actually plug the GPS information into Google and get a map of where you're at right now. It's pretty neat. Onto the combined client. This is the more complicated version. He actually also has a GPS and a Bluetooth module. In this version, I have it running on a battery. This guy, he receives his information out from the sender, and he will take his current GPS coordinates and perform a distance calculation. And if the distance calculation is within a certain threshold, I believe we have it set it to around about 20 meters, a notification is sent out via the Bluetooth module to the smartphone. The interesting thing about this guy is he has only one UART on the Arduino Uno, but we need 3 for serial debugging in the computer of the USB module. We need 1 for the GPS coordinates, and we need 1 for the Bluetooth communication. So we wind up using some bit banging libraries that take over some functionality of the microcontroller and repurpose it for the use in a pseudo UART. A little bit tricky to get working with all the baud rates. You have to be careful that you're not stepping over one another when you're using multiple alternate software serial libraries. And should be able to see on this guy. Oh no, that's the same one. There you go.